Today we are going to learn a new topic, which is linear equations. So the linear equations, we will learn what is the definition of equations, and we will learn how to solve the equation. We'll first learn how to solve one equation, and then we'll expand this to multiple equations, and we will learn the technique on how to solve them. And by the end of the lesson, we will also learn some concepts of the inequalities. So first we start from the linear equations, and we can take a look at several concepts at the beginning, because later on when we say this is a term, this is the coefficient, what is the constant, you would need to know what do we really mean. And by saving time on checking back and forth, let's better get in line first on those concepts. So expression, I think we have been heard this a lot many times. So we write something, when we write down numbers and the combination of numbers, we sometimes call this is an expression, right? Because when we just write down a single number, it's really just a single number. But if it is a combination of numbers and operations, then I can claim that this is an expression. Right? The expression can be very simple as two numbers added together, or it can be as complicated as fractions with symbols, with numbers with powers, and with multiplications, and over a different fraction and symbols. So it can get as complicated as you want, but this is a expression. So mathematically, the mathematical expression combines numbers and variables. Using mathematical operations. Right, so here, numbers and variables. Numbers are really just numbers, and then the variables will usually use a letter notation or letter symbol to represent variables. So variables are non-constant, right? Because constant means a number. A known number, it's a we also call it's a constant, because a known number is a known number. It's already known as 3 or known as 4, so it's a constant, right? But variable means the symbol R or symbol A, for example. We use this notation to represent different possibility of outcomes or different numbers. So this number can be changed, or this number is varying. So that's why we call it variable. So it's non-constant, it's in symbolic, usually in symbolic form. You can use whatever notation. We can use X, Y, A, B, whatever symbolic form notation. And this can be changed. Right? That's the most important thing, because it's not a constant, it keeps varying, so it's variable. Okay. Other concept, a term. Right? A term is part of the expression, but usually do not contain operations like 3x squared. So for example, if I have 3x squared plus 2, this is an expression, but from that, the 3x squared is a term, and 2 is another term. right? So basically, without the operation or separated by the operation, other components from this expression is called a term. So, of course, the term can contains constant only, or it can contains a symbolic form only or verbal only, and it can be, for example, single x is also a term. It can be constant only, it can be verbal only, it also can be a mix of constant and symbolic variable. So there's a constant term. We sometimes just call it constant. It really means constant term. For example, 2 from this expression is a constant term. And then, so the constant term is relatively simple. It's really just a constant. But for non-constant term, or for a variable, for the term that contains a variable, they seems a bit complicated because sometimes it looks different. So one of the, regardless of, they could be different in powers. They also could be different in their multiplier if this variable has been further multiplied to something else. And how to quantify that or how to summarize that, there is a new concept called coefficient. So compare in this example 3x squared. Number 3 is the coefficient of this term or of this variable. So, and it's regardless of the power of the unknown variable. So for example, 4x, the coefficient is 4. Okay. 16x squared, the coefficient is 16. And even for x, it's equivalent to 1 times x. So the coefficient is actually 1. So basically the coefficient is the multiplier in front of or multiplying the unknown variable. Okay, so after knowing those concepts, there's one more concept that leads you to the equation, right? So far we're looking at the expressions and the components from the expression, like which one is a term, which one is a constant term, what is the coefficient from a non-constant term. So then starting from the expression, how do we form a equation? Depends on the concept of equivalent and simplify or simplification. So for example, equivalent means if I have a expression t plus 1 and I have another expression 1 plus t, because addition is commutative, so these two are equivalent, and we use this equal symbol denotes equivalent. Also, if I have minus x plus 6, I have 6 minus x, they are also equivalent. But if I have minus x minus 6 and 6 minus x, they are not equivalent. Right? And then the second important thing is how to simplify, right? Simplification. You also need to know the simplification. For example, later on when you learn equations, you would first need to simplify your equation. So for example, if I have an expression 6r, r is a variable, like here 6 is the coefficient of 6r and r is a variable, 6r plus, sometimes we also call variable as unknown variable because it's not a constant number, it's not known yet, so it's unknown variable. To simplify this, I have a multiplication over or distribute over subtraction. So I need to open this brackets by 2 times 4 minus 2 times 3r. And then 6r minus 6r happen to be cancelled out, so it's 8. The next, for example, this time my unknown variable is written as that. And I have 3 minus 2 that. Okay, so then let's open the brackets first. 5 that minus 15 plus 21 minus 6 that. Now you probably see that by further simplifying this, what a common way or intuitive way to simplify that is always group the similar terms together. Over here, even though I said that it's the same value, different sign, so that be canceled out, but what I'm really doing here is I grouping the similar terms first and then operating them first. So here I'm grouping the terms that contains unknown variables together, 5 that minus 6 that, and then I grouping the remaining of the constant terms together, minus 15 plus 21, and then continue do the simplification because the variable term and constant term can never be further simplified. So if you want to do the simplification, there's no need to put them together at the beginning. You really need to separate them into different groups and then simplify them separately. So this is minus that. 12 minus 15 is 6. And that's it. So that's the simplest form being simplified with a variable and a constant term. Right, so what we learned from here is to group similar terms during simplifications. And here when I say similar terms, that really means group the constant terms together and groups the terms that contains variables separately. And contains variables, it's even can be further saying that it contains the variable with the same symbol. Right, for example, if I have x plus 3 plus 2x plus 4 plus y plus 1, right, I group constants. This time I put the constants in the front, so constant terms are 3 plus 4 plus 1, and then the terms contains unknown variables are x, 2x, and y, but x and y cannot be putting together because they are different symbols. They means different variables. Even if in the future the solution tells you the representing the same number, but in the beginning the meaning of that is that they should presenting different quantities so that they cannot be simply adding together. So that's why I'm writing the non-constant terms further separated by different symbols or combine the same symbol first. So then I have 8 plus 3x because they are both x, so 1x plus 2x is 3x plus y. So this is how I simplify this. Okay, now let's take a couple examples. So solving equations are also usually coming from word example. So in the first example, let's try to summarize or try to rewrite the word example into expressions. So Allison has 3 boxes of chocolates and 5 extra pieces of chocolates. Now the other person, Atlas, has 4 boxes of chocolates and 8 extra pieces, and each box, as we have 3 boxes plus 5 pieces, the other one has 4 boxes plus 8 pieces, but each box has X pieces. So I don't know this number yet, but at least I know every box has the same number of chocolates inside it. I know they are the same number, I just don't know how many exactly, but then I can use one single symbol or one single variable to represent the number of chocolates that possibly contained in one box. Okay, so first of all, let's try to write the total number of chocolates that Allison has. Okay, so first of all, it looks like you don't has a number solution directly. The solution would have to contain a variable, but it's okay, don't worry, because as long as you can use an expression to describing or to summarizing your question, that's your first step. So how many chocolates that you have in total? So Allison has 3 boxes. Each box has X pieces. Other than that 3 boxes, you have 5 extra pieces. So Allison has 3x plus 5 chocolates in total. And I don't know the value of x, but this means if I know how many pieces chocolates are there in each box, I can plug in or substitute the x in to get the actual number of chocolates. But here it is okay. At least I know that Allison has 3x plus 5. The second step, to write out how many chocolates that Atlas has in total. So Atlas has 4 boxes, with each box contains X piece, then 8 extra pieces. So it's 4x plus 8. And then last, I want to know how many chocolates are there totally together by both Allison and Atlas. Basically, how many chocolates in total. So then I can either redo this one over again from the original question, or I can take in the sum of the known conclusion from step 1, step 2. Right? That means I can take, I already know how many Allison has, and I know how many Atlas has. I just need to take the sum. And then see if there's any where I can simplify that. Yeah, I can group the similar terms. So I have 7x and 13 extra piece. And that's it. So we stop here as this example just in order to for you to try to demonstrate the word problem in terms of expressions with terms. So let's see a couple more examples about simplification. Okay, to simplify, let's say the first one, 10t, this time t is the variable, the notation for variable. And this time we have fractions instead of, fraction as the coefficient of t instead of integers. Like, remember all the previous examples when we write the examples of a term and then to tell the coefficients, these are always integers, but of course, integers don't always have to be integers. Coefficients can be any number, can be fraction number, like in this example. So it's 10 over 6t plus 12 over 9t. So that means the coefficient of the first term is 10 over 6. The coefficient of the second term is 12 over 9. Writing them together, it's in fact to factor out the common factor of t and then do the summation of the two fractions together, right? Now, I'm not going to write that many steps, but here, then to take the summation, you will need the common denominator. Between 6 and 9, the common denominator is 18, so that's 30 plus 24, so 54 over 18t, and then 54 over 18 seems to have common factor that you can further simplify. At least 9 is a factor, because 6 times 9 is 54, and 2 times 9 is 18. So then 6 over 2 is 3. So it's actually 54 is divisible by 18, but it's okay if you cannot tell at the first place. You can still simplifying this by keep canceling out the common factor. So this is where the end of simplification of this example. Let's check one more example. So I have a over 2 plus 6a minus 5 over 4. So again, even though there's a mix of the constant and the variables, you can still treat them as fractions. So then addition of two fractions means you are looking for the common denominator first. So common denominator is 4. So I need a 2a over here, and then plus 6a minus 5. And then grouping them, grouping the similar terms, I have 8a minus 5 is an over 4. So this is the simplest form. Of course, there's another way in terms of whether you want to write in a fraction form, that's the simplest form. In case if you want to write this as a term that's separating the constant and the variable, you could further write this as 8a over 4 minus 5 over 4, and then this happened to be 2, so it's 2a minus 5 over 4. So both ways are okay as the simplest form. And then the last example, before we going into the equations, to practice how to group the similar terms that they contains unknown variables, because we know that grouping the constants is really just arithmetic, but grouping the variable, you need to be a little bit careful that you can only group the similar term. And here, when we say similar term, they would has both the same symbol, or they have to have the same power, even they are under the same symbol. So for example, x plus x is 2x. This looks like very straightforward. If I have x squared plus x squared, that's 2x squared, right? This also kind of straightforward. And of course, I have x plus y is just x plus y. There's no further way to put them together, right? So what happens if I have x plus x squared, right? I have x plus x is 2x. X squared plus x squared is 2x squared. So x plus x squared is neither 2x nor 2x squared. None of them are true. You simply cannot put them together. So x and x squared are two different terms. And there's no, in this case, there's no further way to simplify that. They should stay apart as x and x squared. Okay, now let's go into the part that solving the linear equations. Well, what is a linear equation and how to solve that? So first of all, let's review again what is equation, what is an equation. So equation states that two expressions or two quantities or two expressions are equal. Right, so for example, so this is equation. Basically, the two expressions are equal. So for example, equations can actually, it's okay to contain only constants as long as it's true. So if I write 2 plus 6 equals 3 plus 5, it is an equation, right? 8 equals 8. The two quantities do equals to each other. Even though there's no unknown variables, these are all constants, but this is an equation or a kind of equation. Or if I have a plus b equals b plus a, so even this contains no constant but all variables. But this is also true because a plus b equals to b plus a. So this is also an equation. Okay. But more likely we will see in this class is something like 3 plus x equals 6. Right? So this is also an equation. It has terms that contains either constant terms or terms contains unknown variables, and it's linked by a equal sign, and we don't know the actual value of x for now, but we may be able to solve it from this known relationship. Okay, so this is in order to solve equations. To solve there's several techniques that you can use, and again at the beginning I will do this very slow and to express them in a very clear way, but in the future, after you really handle the idea of the steps, you could be able to apply this easily. So the first is to always replace with equivalent expressions. So what do I mean by replaced by equivalent expressions? It is actually just similar to what we learned about simplification. So for example, if I give you a equation of 5x minus 4x plus 3 is 14, before trying to solve this, I can simplify this term, right? And the way I simplify this is because I know 5x minus 4x equals x. So I'm actually replacing this term with a known term. So then this equation, I'm using this symbol demonstrating these are equivalent. So this equation is equivalent to write in the way of x plus 3 equals 14. So this is just replacing some expressions with known equivalent expressions to simplify that. So this is one useful technique. The other one is to apply the same operation on both sides of equation. So this is we usually call it like to moving around terms on both sides of the equation, or moving around the term from the left hand side to the right hand side, or from right hand side to left hand side. This is a very common technique that you would have to handle this, or to using this in a much more frequent way. But here, as the first time you see that, the idea behind that is really that you can do the same operation on both sides of an equation. So simply speaking, you can add the same value at both sides of the equation. You can subtract the same value at both sides of the equation. You can multiplying and dividing the same value on both sides of the equation. The only restriction is that you cannot divide it by 0. Other than that, you can do all such operations, the same operation on both sides of the equation. So here, in order to find out the value of x, if I can move this plus 3 over there, I will have x equal to something, right? So how do I say move? So this equivalent to subtract 3. So subtract 3, 1 minus 3 on both sides. So that I have on the left hand side, I have x plus 3 equals 14, but then I subtract 3 on both sides, so that this 3 plus 3 minus 3 give you 0. So x plus 0 equals 14 minus 3, and 0 is plus 0 is nothing, so x equals 14 minus 3 is 11. So then I know the value of x, means I solved this equation, and x is 11 by using this technique. So I'm subtracting the same number on both sides. So this means if you have plus or minus, you can kind of move the number to the other side of the equation by changing the sign, right? Another example, if I have x minus 2 equal to 8, I'm plussing 2 on both sides, I get x minus 2 plus 2, 8 plus 2, right? And then this gone, x is 10, right? So it's equivalent to move this number minus 2 over here, becomes plus 2, and I can solve this equation. And furthermore, I can use multiplication and division as well. For example, I have 3x equals 18. It means I can divide, right? All I want to do is to isolate the variable, this x. So I have 3x, I want to turn this, like all such operations, by the end, I want to get something like x equal to something, right? A single x equal to something. This is called to isolate the unknown variable. So to isolate x in this case, I have a 3x, which means I need to divide it by 3. So if I'm dividing 3 on both sides, I get 3 over 3x is 18 over 3, right? So it's like moving a multiple of 3 to the bottom of the right-hand side, become 18 divided by 3, then x is 6. Okay, so this are the basic techniques to simplify the equation. And then finally, we define what is equation. So then we can further, like remember here we saying that we're learning linear equation. So what is linear equation? So that would be the last definition here in this lesson. Right, so so we know what is an equation. Now what is a linear equation? And we can see the examples. For example, we just had x plus 3 equals 14. It's an equation, right? We could, of course, have other equations such as x squared plus 2 equals 10, for example, right? Because x can be any form. I can even have one unknown variable x multiplying another unknown variable y minus 2 equal to 6, for example. Like these are all different forms of equations. But what is linear equation? So if every term in the equation is either constant term or a constant times the first power of the variable. Okay, so basically here contains two things. Either it's a constant term or it contains a variable that multiplying by a constant and with the first power only. So if we now examine this again, the first one is a linear equation. It contains constant term. It contains unknown variables multiplying a constant, and the power of this unknown is 1, the first power. Second one, it's an equation, but it's not a linear equation because square is not linear, non-linear. The power is greater than 1, so it's not. And the third one also not, because even though the power of x is 1, but you multiply another y, so the power of the total unknown variables is still higher than 1, so it's not a linear equation. Right? So it doesn't matter how you write a symbol as long as you have single variable. For example, if I have y minus 2 equals 6, that is a linear equation because you have constant term, you have unknown variable, but the unknown variable has the first power only. Okay, so this is a definition of linear equation. And then after that, the whole contents of this lesson will only focus on linear equations. For equations higher than the first power, basically they call the nonlinear equations. You will learn them in the future. Those are would be a bit more complicated than linear equations. All right, so let's see some examples on what are linear equations and how to solve linear equations. The first one, x minus 12 equals 289. This one, as the first one, let's do this slowly. There are actually multiple ways because this equation is simple enough to tell that you're looking for a number that subtracting 12 and you can get 289, which means you're looking for a number that is 12 times greater than 289, right? You can move from the number line, you can solve from the word problem. But now let us solve this as an equation. So then we can use one of the technique. We can do the same operation on both sides of the equation. That means I can plus 12 on both sides of this equation to get x minus 12 plus 12 equals 289 plus 12. So these two are gone together. So my x would be 12 higher than 289, which is 301. Right, so this is how to solve this problem in terms of equation or linear equation. The next example, if my equation is 4 minus 5 and 1 over 5 equals 2x plus 3 minus x plus 3, 1, 5. So this one looks like I want to simplify my expressions on both sides of the equation first, and then trying to solve the equation, right? So simplification, the common denominator is 5 on the left-hand side, so it's 20 minus this, converting the mixed number into single fraction. This is 25 plus 1, 26. On the right-hand side, I'm grouping the similar terms together as I just demonstrated. So the x terms, I have 2x minus x, so it's single x. Constant terms, I have 3 plus 3 and 1 over 5. Common denominator is 5, so 3 becomes 3 times 5, which is 15. This mixed number becomes single fraction of 3 times 5 plus 1, 16, 5. So I have minus 6 over 5 equals x plus 31 over 5. Okay, so then I want to solve this by minus 31 over 5 on both sides in order to isolate this x from here. So I have minus 6 minus 31 over 5 equals x, right? So my x is minus 37 over 5. So this, I've been isolating my x by operating the same subtraction on both sides of the equation to solve that. Okay, I have couple more examples to finish today's lesson. So the next example, I have 5t equals minus 13. Here t is the unknown variable. I have other either constant terms or different coefficient other than 1. To solve this one, I need to divide it by 5 or multiplying 1 over 5 on both sides, right, in order to isolate t. So I get 5 over 5t equals minus 13. I'm also dividing by 5 on the other side. So then these two cancel out. So I have t equals minus 13 over 5. Right? Or if I have another equation, u over 7 is 3 over 14. So this time the unknown is u. All the rest of the numbers are constant, which are known. So I need to solve u or isolate u from here. this time I have u over 7, so which means if I want to isolate u, I want to multiply a 7 over here. So it means I need to multiply a 7 on both sides to get u over 7 multiplied by 7, 3 over 14 times 7. Then this 7 and 7 is gone. I have u is this. 14 is 2 times of 7. So if you cancel out 7, this has 2 left. So it's 3 over 2. Okay, one more example with a negative sign as well. So this one, r is my unknown variable. I have minus 2r over 9 equal to 8 over 15. So it doesn't matter how complicated or what the sign is in front of the unknown variable, we just don't panic, we just do the same operation by canceling out the coefficient in front of the unknown variable. And by the means that I said, cancel out, that's looking for a number to multiplying or dividing from your coefficients to make this equal to 1. So if I have minus 2 over 9, I need to times a minus 9 over 2 to make the whole product equal to 1, right? This will make u equal to 1. So this means I need to multiplying this number on both sides of the equation, and that can guarantee the coefficient in front of r will be turned into 1. So I'm multiplying a minus 9 over 2 on both sides to get equals 8 over 15 minus 9 over 2. And then this is all gone. 9 over 9, 2 over 2, negative times negative becomes positive. So r is, I can bring the minus sign out first. So 8 over 15 times 9 over 2. This is 4, 3, 5. So it's minus 12 over 5. Okay, next example. I have 5 and 1/4 minus y equals 19 and 3 over 4. So this time I'm showing a different way by moving the variable to the other side of the equation first, because when you have a negative sign and you're trying to isolate your variable, like one way is like the previous example, you can multiply a negative number on both sides of the equation, but multiplying negative sign is equivalent to moving the term to the other side of the equation by changing the sign. So this time, if I want to get a positive y directly, it's so-called moving this term to the other side of the equation by changing the sign, and the mathematical idea behind that is I'm really just going to adding a y on both sides of the equation, so that I will get 5 1 over 4 minus y, that's the original terms on the left hand side, and then I'm plussing another y. So same thing on the right hand side, I'm also adding a y. So then here minus 1y and y they cancel out each other, so that is equivalent to, right, moving this y to the right hand side with changing sign from minus to plus. So then y, and then in order to isolate y, I also want to move this term to the other side. And how do you move that? It's by subtracting this value on both sides of the equation, right? So then this becomes 5 subtracting 19, 3 over 4 equals this cancel out, and there's only a y left. So I've been practicing this many examples. You probably already find out that this is really a quicker way or easier way is you can really just move your terms around the equation, but if you move one term to the other side of the equation, you need to change the sign from plus to minus or from minus to plus, and then you don't have to really write this out every single time. You just know that this is the fundamental. That's the reason why you can do this. But how to do that, you can do this in a relatively quicker way. So anyway, here I'm already isolated y. So y is 21 over 4 times 4 plus 3 over 4. So you can simplify this by yourself. So basically, this is how we solve this equation. Next one, if I have 3r minus 7, this time the unknown variable is in a brackets, and then there's additional numbers are outside brackets, so which means I need to open the brackets first. Or if you're observing this question, you have two options. Let's do the straightforward way. If I want to open the brackets, I will get 3r minus 21 is 24. And then 3r is, I'm moving this over there, minus 21 becomes plus 21. So 24 plus 21 is 45. And then no, I'm dividing the 3 on both sides, or 45 divided by 3 is 15, right? So this is one way. The other way, before opening this bracket, I can see this right away that 3 is a factor of 24. So which means I can divide it by 3 first on both sides. So 24 divided by 3 is 8. And so that moving the 7 over there becomes plus 7. 8 plus 7 is 15. So this seems a bit easier than the other way. Okay, the last example, to find the value of c such that x equals 2 is a solution to this equation. Okay, so this one, you need to read the question carefully because in this equation, you have two symbols. You have two variables. X seems to be the unknown. C seems to be another symbol. And two of them form this equation. But by reading the question, we know that there's a known condition that x equals 2 is a solution to an equation. So what does that mean? If I know a value is a solution to this equation, that means if I'm plugging this value back to the equation or the equal sign still true. Like for example, let's see in the last example, this also gives you a good way to double check or to validate if your solution is correct. So that means if this solution is correct, I can plug in or I can substitute back in with the value of r that I found and to see if this equation is still true. Like for example, I claim that I found a solution where r equals 15. So then if I plug in, I have the left-hand side is 3r minus 7, where r can be substituted by 15, so that I get 3 times 15 minus 7 is 8, and 3 times 8 is 24, and this equals the right-hand side, which is 24. So this means first, I can validate if my solution is correct. Second, if it is a solution, it means it can be plugging back to the equation, and the equation is still true. Basically, the equal sign still true. So that means x equals 2 can be substituted in here to get Then x can be replaced by 2, so I have 2 over c equals 3. And this should still equals because x equal to 2 is a solution to this equation. Then what I need to do next is to find the value of c to also make this true. So it is equivalent, even though it's an equation of x, but up to this step, it's equivalent to solve c from here. So I can move c over here and then divide it by 3 over there. But again, just for clarity, maybe let me write a couple more steps. So first one, it's equivalent to be multiplying c on both sides to get 2 over c times c is 3 times c, where c is not 0. So I have 2 is 3 times c. Then I divide it by 3 on both sides. Again, 2 over 3 is 3 over 3c, so that c is 2 over 3. So that I can find the value of c, which makes this relationship true. Okay, so that's all for this lesson.